Hello everyone, Luis here. Let's talk C#. Let's take a look at the basics of the main collection types that are available to us in this language. And I should say, though, this is not something new to us. We actually have worked with collections before when we worked with arrays. Okay, so if you remember, arrays are static in size. Not only that, but they're also static in type. So what does that mean? What that means is that all array elements must be of the same type. We all remember that, right? Arrays have one extra quirk. Array size must be known upon declaration time. Okay, so what that means is that we have to know the size that array is supposed to be when we declare them. Okay, and as you remember, the syntax is pretty straightforward. If I want to declare a string array, I can just do something like this. There are many ways to declare an array. This is just one of them, but it's one that works. Okay, good. So that's the first collection, and I guess that's the most primitive type of collection. Okay, the next one to talk about is lists. Now, lists are a little different. First, because they are dynamic in size. However, lists are static in type. Okay, meaning all list elements must be of the same type. But the most important thing is that a list size changes throughout the list's life cycle. Okay, so if I want to declare a list, here's the syntax. And I'm getting an error. That's because I'm missing a using statement in the top of my file. So I can just fix that by adding using system.collections.generic. As you can see, the error goes away, and that's the syntax to declare a list. In this example, this is a list of strings. Okay, so in these angle brackets that I have right here, I have the option or the opportunity to define a type. That's the type of each individual element in that list. And then from here, if I want to add items to the list, I can just say list.add, and I can just add a string, because this, after all, is a list of strings. Okay. Now there is something called array lists, which are very similar to lists actually. Okay. Array lists are dynamic in size, much like lists are. However, array lists are dynamic in type. That means is that array lists or array list elements can be of different types. Okay, and much like lists, an array list's size changes throughout the array list's life cycle. Okay, and here's the syntax to declare an array list. Array list equals new array list. I'm getting an error here because, again, I'm missing a using statement on the top of the file, using system.collections. Okay, When I add that statement, you see that the error goes away, And from here, I can just go ahead and say arraylist dot add, and I can add a string, I can add a number, and if I want to, I can add a boolean, a person object, anything really, because array lists are dynamic in type. Okay. Now moving on to the next one, we also have something called stacks. Stacks are dynamic in size. Stacks can be either dynamic or static in type. It all depends on how they're declared. Okay, meaning stack elements can be of different types. A stack size changes throughout the stack's lifecycle. Now what I should say is that stacks are philo. So what does that mean? That's an acronym. It stands for first in, last out. Okay, so what does that mean exactly? Think of it as a stack of books, right? You have your desk and you take a book out of the shelf. You're gonna take that book, you're going to put it on your desk. You have one book there, okay? Then you go and grab another book and put it on top of the first one. Now you have two books on the stack. And then you go ahead and take a third book and put it on the top of the pile. So the last book to go on the pile is the first one to get out of the pile. Okay, so with stacks in C#, that's exactly the behavior. So the first element to go on the stack is the last one to get out of the stack. Similarly, the first book you would put on your desk is gonna be the last one to get out of your desk. Okay, so what is the syntax here? Stack equals new stack, and from here I can just say stack dot, this time there is no add method. The method I'm looking for is push, and I can add a string to this stack. They are dynamic in size, so I can just go ahead and say stack.push again, and I can push, say, the number 1. If I want to, I can go ahead and say stack.push, and I can push a boolean variable or a boolean value. Okay, now this is the first item on the stack. This is going to be the second, and this is the third. Now, if this is really a philo kind of collection, first in, last out, if I go ahead and say something like stack dot pop, what's going to happen is that the last item to be added to the stack will be popped out of the stack. Okay, and effectively what happens here is that pop actually returns an object. Okay, the very last object to be added to the stack. So I can go ahead and just say var last equals that. Okay, so again, the pop method will take the very last item to be added to the stack, in this case my boolean value, true. Okay, it'll be popped out of the stack, so at this point it's actually eliminated from the stack itself. Okay, but it's also returned, and its value is going to be stored in this variable, a local variable that I'm creating called last. Now moving on, we have queues. And queues are similar to stacks. They're dynamic in size, queues can be dynamic in type, meaning queue elements can be of different types. Now, words are important. They can be of different types, but they don't necessarily have to. Okay, we're gonna talk about that. We also know that a queue's size changes throughout the queue's life cycle. Now, queues are actually first in, first out. That's the main difference between queues and stacks. Okay, this is first in, first out. That's precisely why they're called queues. Think of a queue when you go to the grocery store. You get on the queue to pay for your stuff, right? Usually, the first person to get on the queue is the first one to go to the cash and pay for their stuff, right? So first in, first out. And here's the syntax. Queue equals new queue. Okay, now this, in case I want to declare a queue that is dynamic in type. I can also declare a queue. I'm just going to call it queue2 a little differently. I can do something like this. And this is going to be static in type. In this case, the type will be a string. Okay. Now from here, I can just go ahead and say queue dot. This time the method I'm looking for is enqueue. Okay, and then again, I can add a string or queue.enqueue. I can add a number or queue.enqueue. I can add a Boolean value. Now, there's also something called linked lists. Even though they are dynamic in size, they are static in type. Okay, meaning linked list elements must be of the same type. Okay. And again, a linked list's size changes throughout the linked list's lifecycle. Okay, so I can just go ahead and say linked list dot. So I can see here that I have two methods to use. I have the add last and add first. So as the name suggests, a linked list is a collection where all elements are kind of roped together. They're kind of holding each other's hands, okay? So I can call the add first method to add something to the very beginning of the linked list. And I can go ahead and say linked list dot add last to add something to the last position. Okay. Now, there are other methods here that I can explore, and I do recommend you take the time to explore all of the methods that are across all different types of collections. But there are also properties, like the first one, the first property. This gives you the very first element on that linked list. So if I wanted to, I could say something like var first on the list equals linked list dot first. Okay, effectively that returns the very first element in that linked list. Okay, and if you hover your mouse over that variable, you're going to see that the type is linked list node. Now from here, I could say something like first on the list, dot, and there's a property here, next, which gives me the very next node on the linked list. Okay, and this is a property that actually returns another node. So I can say something like that. Okay. Now there are other types of more sophisticated collections too, such as dictionaries. Now dictionaries are dynamic in size, much like the other collections we've talked about, except arrays. Dictionaries are static in type, meaning dictionary elements must be of the same type. A dictionary's size changes throughout the dictionary's life cycle. Now, something important to know about dictionaries is that they have a key which is associated with a value. Okay, so dictionaries are going to work with key value pairs. Okay, there's always going to be a key, and that key is always associated with a value. Much like a dictionary, that's actually precisely why they're called dictionaries. Okay, so how do you declare a dictionary? You're going to say something like dictionary, and you're going to have to define a type for the key and a type for the value. In this example, I'll declare a dictionary where the key is a string and the value is also a string. Mind you, however, both of them can be anything. I can have a string for a key and a person object as a value. Okay. Now I'll call it dictionary and say it equals new. And by the way, something I should say, in case you haven't noticed, is that we're using the new keyword for almost every collection here. So what that means is that, well, one, I'm creating a new object of this type, but also this is a constructor call. Now I can go ahead and say dictionary.add, and now I can define, say, a person ID, maybe 1, 2, 3, and then I'll just say a person name, but again, it could be a person object, right? So I'll say this one is John, and I can go ahead and add another one, dictionary.add. This is going to be 321, and I'll add Mary. Now, whenever I have to retrieve a value from the dictionary, I can just say person, var person equals dictionary, square brackets, what goes in the square brackets? The key of the item that you're looking for, like 1, 2, 3. So what's going to happen here is that the dictionary is going to look for a key that equals 1, 2, 3, and it's going to return the value associated with that key in case the key exists. Now, very similar to dictionaries, there are hash tables. Hash tables are dynamic in size. Now, hash tables are dynamic in type. Okay, that's the main difference between dictionaries and hash tables. Okay. So hash table elements can be of different types. A hash table's size changes throughout the hash table's lifecycle. And like dictionaries, hash tables have a key which is associated with a value. And here is the syntax to declare one. Hash table equals new hash table. And much like dictionaries, I can call the add method. And then I'm going to pass in a key and a value, which in this case will be John. I can also go ahead and say add, and this time pass in a key which is an integer and a value which can be a boolean. Okay, so they are both the key and the value, they're both dynamic in type. Okay, and if I want to retrieve an object from the hash table, I can just say var item equals hash table square brackets, and again, what goes in that square bracket? The key that I'm looking for, say the number 1 for example. And again, like the dictionary, the hash table is going to look for an entry which key is 1, and if it finds 1, it'll return the value associated with that key. Okay, I think this is all for this video. Remember, the intention here is not to take a deep dive into C# data structures. In fact, we will look at them in more detail in another opportunity. I just wanted to cover the very basics so that we can continue to the rest of the course. In the meantime, I'll be available in the comment section or by email in case you have any questions. See you next time.